Guys, so this video is for anybody who is trying to be an engineer, and I think that's basically all of us. And why it is because now almost all of the jobs require you to have the AI. If you are trying to be build out the product of your own, you need AI. And then if you're trying to, let's say, to start the career, you need AI. And the curriculum in the colleges that are taught is very different. The products that we have been building till now is very different. The way we have been building till now is very different. It's just completely different. So what we're going to talk about today is like what the AI engineer is supposed to do and what you're actually supposed to do to actually become the AI engineer. It doesn't matter if you want to just go and get the job or if you want to actually build the product of your own. This is the skill that you definitely need. So I was just going through Twitter, and this one is one of the actually I would say recommended thread. I will paste it in the bookmarks as well below the YouTube video. So if you look at it, the first thing that I think is important for you if you want to learn let's say the about LLMs, about AI agencies, Python, and I would say JavaScript on there as well, because these two platforms have built a very good ecosystem for you if you really want to learn how to build the agents. And the reason behind that is, first of all, they are like very dynamic in nature. You have a lot of packages already over there. For example, for Python, all of the complex models that are there, or one of the complex applications that are there, are actually built on the top of the Python. You can look at the TensorFlow that has been there for decades, or you can get the PyTorch on the top of which one of these platforms are built, such as OpenAI's GPT-2 or GPT-3. And when it comes to JavaScript is just the ecosystem that is just so popular with all the developers that if you want to build something using AI or you want to deploy something using AI, you will probably end up actually deploying it on JavaScript. So both of these platforms are very important. Actually, if you go ahead and try to learn TypeScript, it is even better than the JavaScript, because the ground code system that itself that you run on your system is actually built on the top of TypeScript. It was released as part of one of the applications I think that has happened in the past, where I think people figured out that almost all of it was actually written on TypeScript, and even though 2% of it is actually the code where it uses LLM to figure out what to do, then 98% of it is actually just the platform that is built locally. And that is what we're going to talk about, that what actually is code, what actually are the AI agents. And if tomorrow you have to develop something where you maybe want to, let's say, build a travel site, or you maybe want to build out something where you want to research something online and then publish it as a content, right? So it can be anything, but approach is going to be very different. So yes, Python and the learning about JavaScript was very important for you if you don't already know. This is fundamentals basically. And then the second thing is LLM fundamentals for agents. Now this one is, let's say, a very complex topic for me, because the point is you don't really know what fundamentals you mainly want to start with, because it is such a vast area, right? You don't know if you want to start it by learning everything about how the LLM works, or you maybe just want to learn the basics, right? So it's very complex, and we want to break it down in this video, that from where you can probably start today if you have to learn about LLM fundamentals. So to start with, basically you have to know that everything that is there, just give me a moment. I'm going to open the Figma and then show it to you here so I can write it down. This is like very ad hoc video. This is the video where basically I have no idea what to talk about. It's going to be like open video, and in future I will also maybe do it on Discord, where I will go online and then I will try to talk with all of you guys live. And the part about me, basically, I have been using AI for the last 1 year. I have built some of the applications on the top of the AI as well. I kind of now am a bit familiar, but I'm still trying to learn. And I think this is also part of my learning that I'm coming to you guys and then trying to figure out. I don't know what is going on with this here. Thanks. So now let's look at the stage one, which is basic fundamentals, right? So the stage one is going to be JavaScript or Java and Python. So both of these languages are very important for you to learn. It's basically the requirement at this moment if you want to think for it this way. The second things are going to be about the fundamentals, right? That's the agents fundamentals, LLM fundamentals. Now the actual fundamentals of it are very, let's say, very hard for you to grasp at the moment if you are trying to be a beginner, or if you are not a beginner, or if you're intermediate, or if you're expert at, let's say, your platform in any of the languages, it might be easier for you to understand. But all of the LLMs, all of the development started from the transformer architecture basically. This might you get mind asked about it from one of your interviews if you're going to get an EA job, which is that transformer architecture was what was actually developed at Google, which enact the transformation of all of these AI models that are coming in from example GPT-2, GPT-2, GPT-3, GPT-4, and now on 5.5, and then Google released the Gemini Flash version and everything. And if you know about it, it's actually the DeepMind. The people who actually built out this platform were from DeepMind. So their team has been, let's say, they have brought up such a fundamental concepts to the world that OpenAI wasn't possible without Transformers architecture. They now use much better concepts, let's say. They don't just use the raw version of the transformers. They have modified it as per their own use cases and based on the learnings. We'll talk about that as well. But today's topic is not about transformers architecture or about the LLM fundamentals. Today's topic is more about the agents, and that is what you're going to, write down in this video. So yes, the context management is, and then we are going to learn about context management because we will build on one of the AI agent which is going to let's say crawl and over arXiv. arXiv is basically, if you don't already know, it is the platform where all of the research papers are published, and you can go ahead and then try to search about computer science or AI related research papers over there. And rather than us doing it, we are going to let AI agent do it first. And then the model routing is basically which model you want to choose, and then the token economics is very important. The token economics is so important at the moment because if you look at it, Uber recently, they stopped AI usage in their team, and then they told them that they are only allowed to use $1,500 per month. So they have burned out of their AI budget for complete 2026 basically. So you already know that token economics is going to be thing of the future. Maybe till now, all of these companies that are there are already subsidized. So maybe when you actually use it, maybe when you actually use the platform like Cloud or ChatGPT, you're not actually going to pay for all of the cost, but in future it's changing, especially with everything that is going on in the world. So if you already know that Fable 5 is banned publicly now, and government has actually banned it from everybody else to use it other than the US citizen, and I'm not even sure how many of the US citizens are themselves allowed. The redundancy trade-offs have always been there, and the failure modes have always been there. We will talk about all of this in the script that we're going to write down today, and the tool calling plus the structure output. Let's get into the topic list. I actually start writing down the code itself and then see how it actually works. So what exactly is the tool calling? I have already written down some code for us, but what I'm going to do is rather than actually just screaming over the book, we'll write it down just one more time for all of us. So you guys already don't know, I acting as Emacs, and in this system I haven't really installed in terms of extent is it's okay. We don't need to worry about it. So what I'm going to do is I'm going to start a new session of Emacs. So we're going to let's indent out on the agent press. Yes. So to start with, we'll learn what are the tools basically. So what are exactly the tools? So the tools are basically, let's think about your LLM, right? Let's say you go on open router is where you get access to ChatGPT or other models, right? And then you want to integrate it with your system, and then you want to ask something to ChatGPT, and then say that, okay, ChatGPT, I would like you to perform the research on the internet where you're going to get all the research papers, and then based on it, I would want you to synthesize the results and then tell me what are the actual research papers based on my goal, right? And then write it down as a notes.md. Now, on this, there are two things that are happening. The first thing is that you are going on the internet and then trying to search the research papers, so that you need to actually give this access to your model where it can actually do and perform that search for you, right? So the way that happens is, first of all, is that, let's say, give me a second and go to not write down code by my own in the moment because demos one is big, and I think we don't also want to waste the time for that too. Just tool in itself, you can say, where we are going to make a call to this API endpoint, and then we're going to fetch all of the results, right? And after we fetch all of the results, we are going to get the titles of these research papers and then add them over there. And then, of course, the content as well. So let's go back to it and now try to add the other tool as well, which is like, we want to not only get the research papers, but we also want to write them in some notes.md file, let's say, right? So for that, we are going to write down another function here, which is going to be about write file. So this write file motion is basically going to write down the notes.md over there in your platform, and it is going to write it down in your directory wherever the project is open, right? Don't worry about copy pasting this code because I'm going to paste it up on the GitHub, and then you can literally use it for your own purpose, right? And I'm going to paste it in the YouTube description so you can start using it. Now, this is where, let's say, the simple functions that you are already aware of, that you probably either write down whenever you have to do some of this stuff. But I think what's going to be new for you is what the system prompt is. Now, you already use ChatGPT, and whenever you have to ask ChatGPT something, you write it down and then you send it as a chat message, right? Now, the detail that you send as a chat message is the prompt, basically. And the system prompt is a message that you're going to send to LLM so that it can understand your requirements. So it can understand what the profile of the ChatGPT itself is. I'm using the word ChatGPT because just to make it sound familiar, but it is basically LLM models. It can be anything. It can be DeepSeek model if you want to use that. So what you have written down over here is that you are an agent with the tools like web search and write file, which are basically the functions that have written on the top. And you must follow this exact sequence. So the sequence is that you must call the web search exactly once with the search query, and then you must write down in somewhere. We have written down specifically notes.md, and then after everything is done, we need to call and then return this response, which is basically done is true, and then a reserved summary, whatever the summary is already over there, right? So we are basically giving it the instructions that it has to follow, because basically whenever you talk with the ChatGPT on ChatGPT app, it is basically very random in nature. It doesn't know, you don't know what it's going to reply. It can reply with the one paragraph, or it can reply with just one line, right? But we want it to be consistent for us. And what LLM can do is LLM can actually return the JSON response. So that is something that you have to know, that LLM can take JSON response and LLM can return JSON response as well. And after they return the JSON response, you can parse it and then you can do the things that you would want to do. So if you look at it already, what we have done is the stage 2. The stage 2 was about the tool calling, right? So this was the stage 1, and this was the stage 2, which is about transformers and architecture, which we will talk about later in the future as well, right? Now, if you look at the tool calling, which is the stage 2, which you have to learn. When calling. So the tool calling is basically the thing that you're going to do out here, because you want to do the web search and then you want to write down some final locally as well. You don't just want to get the response from ChatGPT, but you want to perform and execute all of these things for you. So what we have done is we have introduced two tools. One is to write down the file, right? And the other one is that it's going to perform the tab search. The second thing that we have done is we have actually given it some of the instructions, right? and those instructions are basically in plot, and where it's basically you can say JSON out, right? Basically it's going to return you the response in the JSON, which you can parse and then which you can use. Now how are you going to use it? First of all, how are you going to call the LLM, right? Like does LLM live on your system? No, LLM lives on the platform, can live on OpenAI, because OpenAI has their own development platform, but the API that I like to use is OpenRouter. So basically what you're going to do is you're going to call OpenRouter, and then you're going to use the post method, because you're going to call them and then send them the request which you have to return the response. It's based on the request we are sending. And then you're going to use the OpenRouter API key. I have already configured it. Please use your own key. Please configure it and then add it as the environment variables. And the model that I'm going to use is Gemini 2.5 Flash. These are the messages that I'm going to set. And the temperature is 0. The temperature controls the variance in the response of the LLM itself. The higher the temperature is, the random the response is going to be. But for now, we want consistency to be there, so we don't want the randomness. And how are you going to make sure that the LLM is able to call the tool? Then LLM is actually not going to call the tool. What LLM is going to do is, LLM is basically going to return you the response, which could look something like this, which could look like, okay, the tool is web search and then arguments have this. So LLM is going to return you the JSON. You're going to pass that JSON to the actual function. You're going to look for the response from that JSON function that you will again pass back to LLM. And then LLM will again come back with the result where it might say that, okay, write down the file. This is my summary. And after that, the LLM is going to say, okay, now I'm done with my job. I don't need to go into the loop, right? So this is the loop that we'll talk about. And this loop is very simple. Don't go at the code. It is like looks complex on the go, but if you say it is basically the messages, right? So the role of the system is basically us, the system prompt that you're going to give, and the user is basically the user who is actually going to perform the query. The system prompt, you can think of it as your job profile, and the user is basically what you are going to use on your ChatGPT application, like sending a message. Later on, we will try to perform the search. We will see how the user actually perform the search. So the goal is going to be something like, hey, I would want you to perform the research on the arXiv and see what are the latest research papers for vision, and then write it down as a notes.md summary. So it's going to call the LLM. It's going to look for the response. It's going to see if it is JSON response or not. If it is done, then it is going to return the response. Basically, the notes are already written, and otherwise it's going to call the tool. Basically, over here, what's happening is, if you see over here, the tool is object in itself. This command or tool is going to be the response, and this response can be basically it can be like write a file, right? Or it can be perform search. Basically, it can be like that, and then the arguments are going to be basically if it's going to be, I don't find, and it's going to be some nail the AI notes that's going to be there. So that is how it's going to first of all do the search. What was the function name that we were using? I think is what we check. It is a web search, right? So the first one is going to be web search. That okay, like perform the web search, right? Now the tool name is going to be web search, and then arguments are probably going to be something like how many arguments does it take? Just one only, right? So arguments are going to be something like this is also what LLM is going to decide. It can be computer vision or something like that, where it is going to search for it on the arXiv and then return back this on, which it will again try to provide the summary of, and then write down as the AI notes. And then after everything is done, it will return back the response where the command will be true, and then it will just return back the result. So but to execute it, of course, you have to start this function as well. So in the real world, you don't need to worry about it. It's going to be called from some API response, but just because over here we're going to use it as a CLI, I'm just going to process the arguments that I give to the CLI and then return back the response. So let's try to run it now. There is my terminal right there. Okay. So let's say I want to run it, and then I want to give it simple message, which is find the latest AI research papers on the reasoning model, right? Or let's say for this term, I would say computer vision models, right? Now then I perform the search or when I actually call this file itself, what you will see is that first of all, the tool is going to get called, which is web search, right? The second thing is that it has passed the arguments already. And these arguments, basically it has passed out from here on its own. If you see it, the find is not there, right? If you perform the different search with the different, let's say, naming, it will be still able to figure out what it actually need to search on the archive, right? After it performs the web search, it's going to take a bit of time because of archive. Probably the API is returning the response in slower time. After it returns the response, it's going to send and write down and gives you the output that okay, now you need to write down the file in the notes.md where you will be able to, let's say, write down the summary, and after that the job will be done. Okay, so now it has done its job. The web search, first of all, it was able to do the web search, and after it returned you the response. This was basically sent as the request to the LLM again after it has figured out that okay, these are my 10 research papers. Let's see, it will send back to LLM again, and LLM is going to be like, okay, now write on the file, and arguments are going to be notes.md or whatever the response that you would want it to give, and then you're going to write down the notes.md, right? Take me limit for table is it's actually 503. So 503 is actually the error code that you have got from arXiv. It was not able to give you the summary. Let me search one more time. Let's see if you're able to perform the search again, because it's been there on the archive side. The API might be down. So I do use ChatGPT a lot. I have just asked ChatGPT that if it can let us know if the problem is with the archive itself, because just because it knows the code, it will be able to help us debug easier, because it can just call the open router, or it can just call the archive and then return back to you the response, right? So what's happening is that archive export API is returning us the 503 because probably either they have long task because they have way too many calls, or because of something else. But let's see if ChatGPT is able to help us debug the issue or not. Okay, it worked this time actually. So this time what has happened is it has logged the reply notes.md, and let's first look at the response, and we are over there. Take it to some error. Probably if you're stuck in this part of the video, I just want to let you know of one thing, right? Do you use ChatGPT or not? Do you use Cloud Code a lot? Doesn't matter which your favorite API is, or what your favorite system is. Because what's going to happen is that you would want to do all of these things very fast, right? You would want to make sure that you are able to debug things properly or not. And the way to do that is through ChatGPT. Just like I was able to take the error and then give back to ChatGPT so that it is able to debug and help me properly. This is the vibe coding. The vibe coding is not you telling ChatGPT that hey, you want to develop some product and then it developing the product for you just in one prompt. No, it is very much like you can say you have to think through all of the thought process of what you really want to build, and while going through it you may find out some errors which you have to resolve. So it is not going to be straightforward. It is going to be the complex process of thinking through ideas, right? Okay, let me just run it again and let's see if it is able to record this time now. Okay, so it has performed the search. It was performed the search last time, and so on, of course. And let's see if it is able to return back with response from arXiv this time. See, so it has performed the search, and it has written down using the file as well, and it has written down the summary. Now if you look back into bookmarked.mb, you can see that it is based on that I research. These are the actual research papers that it was able to figure out, right? Now we have not gone in detail. We were able to calculate that okay, now you not only need to perform the search, you need to look at the paper as well, and then you would need to do some of the experiments, but you can potentially do that just the way you was able to write down the notes.md file for arXiv. You can do that also for your own research, right? You maybe want to go on Twitter and then try to figure out your own content, or you really want to go on the Google and then try to perform that, right? And for that, one thing that I would tell you is you might want to know about parallel.ai system, or you may want to search the Perplexity APIs. Because what you can do is you can use the Perplexity web platform. You can perform the web search of your own and then save the results, and you get the handle those results online however you want to. So that is what the doom calling is all about, and you might want to learn more about it.
The memory and the state management is where, let's say, the state that I'm managing is but other research papers we have actually already researched, right? And you maybe want to just cache it basically, and then serve it from the cache whenever the user is asking about it for one more time or again. So that is what the state management and memories are going to be all about. So it is for short-term memory, it is going to be about long-term memory. Now in memory, the another thing that you might get to hear is the vector databases or the other kind of databases that have come up based on the memory search requirement, right? So for that, we'll cover that in another topic. But memory and state management are going to be very important for you to learn. The single agent workflow is what we have already covered, but the multiple agent orchestration or workflow is going to be where, let's say, not only you have one researcher who is going to search on the arXiv, but you have another researcher who is going to research on the parallel.ai, on Google, on Bing, and then try to figure out the past research papers. And you are going to synthesize the results from all of them and try to save it, right? So today we covered about the agent, which is single, but we'll look into the multi-agent orchestration as well. The human in the loop systems are going to be very important for you, because what you want to do is you want to build up the platform. There might be some improvements in what, for example, if you are not just navigating nodes.md, but you have to publish it, right? You would want the human to be in between before publishing it. So how and why you need human in the loop? You need to know first of all uncertainty of the decisions, right? If it is something that is going to be very important for you, critical for your reputation, critical for the money part, you need human in the loop. And human in the loop is basically nothing but LLM giving the response to the human so that human can approve it. But it gives a response in a meaningful way where human themselves don't have to go on arXiv.org and try to figure out the research papers. It can just look at the notes.md and try to approve it, right? So this is basically easy, and when you can see that sits in between the LLM and the actual real world. But in critical systems, it is a bit more complex as well. The evaluations and the quality assurance are going to be very important for you, because these are basically test cases for your system, right? So if I just want to talk about it, it is basically if you want to have some bar over what kind of a notes.md files are going to be written in the deterministic world, you can just say, okay, if the response is 200, then it's all good. But in this world, you have to actually interpret what the response is going to be. Is the response faithful, or if the response is carrying the actual resource files or not, or the references files or not, right? So all of those things are going to be very important for you. So you do want to search what evals and then learn how to do it. The best article for it is through Anthropic. So if you look for Anthropic and you look at this blog, it talks a lot about evals, and then you might be able to actually learn a lot about how the evals work. So yes, if you are going for building out the product, you might want to go through this research paper. I'll write it down in the description as well. The observability and tracing. So basically you want to if you ever have to deploy the system in the production, and then you want to know if your system is not going to break in the production, you have to keep the logs, right? So adding the observability on the top of LLM is also important, just like on the API, right? If API is going to return the internal server error tomorrow, you want to add that log so that you can act on it. In the same way, you want to add the observability logs on the top of LLM as well, just in case it is responding as row, just in case it is able to just in case it is hallucinating and not returning the proper JSON responses, right? So observability becomes very important for you to make sure your system is running reliably. And then the security and guardrails and the production deployment and open source plus portfolio. So we will figure out all of these things slowly and eventually. But in today's topic, I just wanted you to figure out what the rule calling is and what the single agent workflows are. And because these are basically the top requirements for you if you want to clear the interviews for the AI agent, or being the AI engineer, or you want to build out the product of your own. As you have, or I guess, do comment down. And in tomorrow's topic, I'm going to actually cover the agent requirements, because what's going to happen is that these platforms are going to become increasingly complex, and they need something which they can iterate over. And guess what agent harness is going to be about. Agent harness started from cloud code, where cloud code is able to use the NLM to write down the code for you, but cloud is also about system itself, and how the system themselves work, and how the system themselves are able to iterate over themselves and then build the better version. And that is what the Fable was on about, which is like Anthropic publishing that it occurs self-improving systems are in the future. So here go to talk about it in the when AI builds itself. Yeah, this is the interesting blog which you may want to research about. But basically, this is when AI it's able to build itself. AI agents are themselves able to do the research and try to figure out what are the code and they need to write down, and they're able to build the better version. And that is what we will talk about in next video. Yeah, that's it. I will write down all of the code and then publish it on GitHub. You will see it in the GitHub in the YouTube description. Thanks for following. If you have watched the video till now, thank you. Do subscribe and add a comment. Thank you.